All right, so today in our notes, we are going to be solving equations. This is number 9. Let me number that correctly. Guys, you'll notice up here the date is incorrect. This should be 11/13, and then not 2015, but 2018. All right, this is just a notes paper that I've been using since 2015. Real quick, guys, before we start this, today we're going to be talking about adding and subtracting equations. I know you all know how to add and subtract. Okay, I know you know how to add and subtract pretty well, hopefully. All right. Everything that we do today, guys, is going to be it's called a one-step equation. Again, can y'all do one step in your head? Yes. All right. But here's kind of the dilemma. What we're doing today is literally the foundation for every equation you will ever solve. We are going to do the first step for any equation out there. All right? Today we're going to talk about if you start with adding and subtracting. Tomorrow we'll do multiplying and dividing. But guys, after today and tomorrow, you will know how to do the first step for every single equation you will ever see. Okay? So, here's the thing. Do you think it's easy to learn one step when you're just doing one? Or do you think you should wait to learn how to do one step when you get to where you're doing 4- and 5-step equations? Do it now, guys. All right? And guys, it is so important that we learn to do this one step now, the way that I'm going to grade it. Your work, 3 points. Your answer, 1 point. Okay? That work is so important to me that it's going to be the predominant part of your grade. Okay? So if you get the wrong answer, but you do all the work right, that should benefit you because you'll get more points. All right? If you're like, I'm doing this all in my head because I'm so smart, I know what's up, okay, then that's probably not a good situation to put yourself in because you're going to lose 3 points out of the 4 in every single problem. Jacob.
Not very much. If you look on the back, you're not going to get any answer wrong. You can check every single one of your answers.
And we're going to talk about how to do that too. That's going to be a big part of today, okay? Holland?
What if you do the work, but you get the work wrong? Is that still 3 points off?
Mm-hmm. If you do the work wrong, then we're doing the problem wrong. And when I show you the work, it really is obvious. It's easy. It's one step. It's going to be easy. I just need you to show it to me correctly, okay? Joelle.
When we are doing the one step, if we miss one part of
It's one step. If you miss one part, you get it wrong.
Okay.
Okay? Because it's one step. There's only one thing for me to see you doing. Does that make sense?
So when we get the higher grades, when we do multiple steps, so we get to the software now.
That depends on your teacher. It depends on how they do their grading. I'm telling you how I'm going to grade your problem right now in math class in 6th grade. All right, Jay? I'm sorry? There's going to be variables in every problem we do, so I don't understand that question. There's a variable in every single problem we do, and you're going to work it a certain way. Okay? All right, so guys, let's write out our definitions. An equation is a math sentence that shows 2 expressions. You should be writing this down. Are equal. An equation is a math sentence that shows 2 expressions are equal. So sorry, guys. To show something's equal, it's going to need an equal sign. All right, so guys, we're going to put a star right here. If you don't like to draw the 5-pointed star, some people have apparently said they've had some trouble with that. Guys, all you're going to do is do a plus sign and then do an X on top of it. There's you a star. Plus sign with an X on top makes a star. All right, so if you need that little shortcut, there you go. All right, but we're going to put a star, and we want to make sure that we know an equation must have an equal sign. Tyler, you need something? All right, an equation must have an equal sign. A solution is the value of the variable that makes an equation true. So guys, basically the solution is your answer. And it's your answer because when you put it in place of the letter, because remember all a letter is doing is holding the place for a number. Well, when you find out what number it's waiting on, if you plug that number in, it should work. You should get that one side equals the other. And then the solve. So what solve means, guys, this is what your directions are going to tell you. So basically, your equation is your problem. Your solution is your answer. And when you see the word solve, that is your direction. That's what you're going to see in your direction. All right, these are your directions to find the solution to an equation. Okay, so that's your problem. It's called an equation. Your answer is called the solution. What tells you to work it out is the word solve. All right, which is different from the word evaluate. If you're told to evaluate, it's going to tell you what the letter is, and you plug it in and work it out. If you're told to solve, now you've got to find out what the letter is. Do y'all see the difference? Evaluate tells you the letter. Solve, you have to find the letter. All right, in order to solve, in order to find the solution to an equation, we are going to isolate the variable. If I get the variable by itself and there's an equal sign, well then automatically in the problem it's going to tell me what the variable equals. So we want to do something called isolating the variable. What does the word isolate mean? Drew?
To focus on it.
To focus on it. What's another thing that isolate could mean? Kaylee?
Put it in somewhere where it's not going to be seen or touched.
Okay. That's getting closer to what we're looking for. Rylan? To put it by itself. The word isolate just means like it's not going to be with anything else. So kind of that's where you were going with it, Kaylee, and that's what Drew was kind of getting to. But the word isolate means that we're just wanting to get it by itself. So isolate means to get the variable by itself. Okay? Now guys, when we solve an equation, the most important symbol in an equation is the equal sign. All right, so I'm going to move this down some. All right, making sure I can still see what I'm doing. All right, I'm going to zoom in a little bit on number 1 so y'all can see my work better. All right, where that equal sign is, that's really important because what it does is it splits my problem into the left side and the right side. And to make that really obvious, guys, I'm going to draw a line going through the equal sign. So now I can clearly see there's a left side and there's a right side. My line split that up for me. Are y'all okay with that? And your line is always going to go through your equal sign. It just splits them in half for you, all right? If I look on the left side of that problem, that's where my letter is, isn't it? That's where my variable is. That's where x is. All right, right now is x by itself. No. Right now it says x plus 3.82. X isn't by itself. It's got this whole other number hanging out with it. All right? We need x to be isolated. We need x to be alone. So it's kind of like x is grounded. All right? And I don't know how it is when you, like at y'all's house, but I know like at my house growing up, if I got grounded, like your friends ain't coming over, you ain't going to no one's house, go ahead and move the TV on out. Like you're not doing anything. Okay? So that's kind of what's happening here. X has to be alone. All right? And the way that we're going to do that, all right, is basically, guys, you're just doing the opposite. So I want us to think for a second. Right now this has 3.82. What operation could I do to get rid of my 3.82 right there? Joelle? All right, no, I said operation. Dylan?
5.1 minus 3.
All right, 5.1 is on the other side. I'm not thinking about 5.1. I'm thinking about, hey, right now this x has a 3.82 there. I got to get rid of it. I need it gone. How am I going to do that, Jay? I'm just going to do minus 3.82 because I want you to think about something for me real quick. 3.82 minus 3.82, what does that give me?
3.80.
Let's try that again. 3.82 minus 3.82 is 0. Guys, that's 0 now, right? And if I have x with 0, is there anything there?
No.
No. So guys, what's happening is this is going to become 0, and we're left with just x. Isn't that our whole goal? Our goal is to have just x. All right, so guys, I want you to think of like your balancing scale. So I'm going to use my pen kind of like a balancing scale. All right, I took the 3.82 away on this side, didn't I? So that's going to make this side lighter, so it kind of tilts like that. Can my equal sign, can I have it tilted? It's equal. It has to stay flat, right? So if I take my 3.82 away on one side, what do you think I'm going to have to do?
3.82 on the other side.
Take it away on the other side. I've also got to take it away here so that that'll even out, okay? So I took 3.82 away here to get 0. I'm also going to do it on the other side. Make sure you carefully line those decimals up because we're going to have to do that subtraction, okay? Are there any questions on why I'm taking the 3.82 away on the other side? Jay? If I do it on one side so that they stay equal, I have to do the exact same thing on the other side. Okay, we have to do the exact same thing on both sides for them to be equal.
Why did you put an x under the number on the left?
This x just came down here because that was the only thing left.
Okay.
Okay, so now guys, let's do the subtraction. All right, that line is where the equal sign is going to go. So it's going to say x equals, and then we're going to figure that out. In order to subtract those decimals. So guys, a lot of people today, we've started working this and they're like, oh, this is more than one step. Really, what did I do? I subtracted on both sides. That's my step. Now, subtracting decimals, we're going to have to borrow and do all that. So it might seem a little longer, but it's just because it's decimals, and we have some more. It just takes some steps when you're subtracting, all right? So in order to subtract these decimals, what do I need to do? Joelle.
You need to make sure that all the numbers are
Sort of on the right track, not quite what I'm looking for. Cameron? I need a 0 next to the 1, so I need a number over the 2. So now, guys, I'm going to go ahead and try to do that subtraction. 0 minus 2. Can I do that? No, so I'm going to borrow from 1. 1 changes to 0, and then my 0 is going to change to 10. 10 minus 2? 8. 0 minus 8, can I do that? No, so I'm going to borrow from 5. 5 becomes 4, and the 0 next to it is 10. So we actually ended up with two 10s next to each other, which we don't normally see, but that's okay. We did it right. 10 minus 8 is? 2. Make sure we keep our decimal. And 4 minus 3 is? 1. So my answer here says x equals 1.28. My answer. So, guys, that is my answer. Now, here's the thing. On your homework and on your review and on your quiz Friday, not only do you have to be able to get your answer, I want you to be able to check your answer. Because before you turn anything in this section, you're going to check it to make sure you have it correct. And the reason I know you're going to check it is because I'm going to give you points for checking it. It's part of, like, the test. All right? So we're going to check our answer. This is our answer. We just want to see if it's correct. All right? So I'm going to put a little check mark here because I'm checking my work. Okay. That was inappropriate and that was rude. You're not going to do that to other students and you're not going to do that to me. Okay? All right. I know it was just a joke, and I know it was funny, but there's a way to be funny and there's a way to be ugly, okay? We're not going to do that. All right, real quick, guys. This right here. What did my original problem say? In my original problem, do y'all see where it says x plus 3.82? London. I need you to stay facing the front. I need you to be focused on my math class. All right. Do y'all see where it says x plus 3.82? All right. What did I find out x is?
1.28.
Look at your answer. What did I find out x is? 1.28. That's what I just decided. X is 1.28. So right now, to check my answer, instead of writing x plus 3.82, I'm going to write 1.28 plus 3.82, and what should it end up equaling? That 5.1. So let's write that out. 1.28 plus 3.82, making sure we line up the decimals still. Okay? And guys, I'm actually working this out. Like if I just write it out and put what I think it should be underneath there, have I actually checked anything? No, I might still have the wrong answer. So 8 plus 2 is 10, carry the 1. 8 plus 2 is still 10, plus the 1. 11, carry the 1, make sure we keep our decimal. 1 plus 1 is 2, plus 3 is 5. Was 5.10 what we were looking for? Yes. Guys, is 5.10 my answer?
No.
No, this was my answer. This just means, hey, check, that was the right thing. Did I get it correct? Yes. What if, you got to check your answer on all of them. All right. What if I checked my answer here and I didn't get the 5.1? Maddie? Then I'm going to go back and redo my work. I might want to check and make sure I did it correctly here. If I know I did it correctly here, I'm going to go back to the very beginning. Okay? All right. Let's look at the next one. So again, there's my equal sign. I'm going to draw my line. All right. What operation is happening here? True?
Addition.
It's addition. So what's the opposite? Subtraction. Raise your hand if you can tell me what number am I subtracting from both sides? What number am I subtracting from both sides? Aaron?
18.
18. How did you know we were subtracting 18?
There's an 18.
Where is the 18?
Oh, behind the equations. Oh.
It's not that it's behind the equation. Why does the 18, why is that the one that matters, Jay?
Because y got to be by itself.
Because y got to be by itself, and what's with it right now?
18.
18. So 18's got to go. You got to go home. Can't hang out here, okay? All right. So we're subtracting 18 because it's the number that's with y, with my letter, okay? Jacob?
18 left Y's house and it came into 72's house that left that house.
Exactly. All right. So guys, 18 minus 18 gives me 0. That goes away. So what's left on that right side?
Y.
Just y, and I'm going to keep my equal sign. Guys, where that line is, you're going to realize that's always where your equal sign goes. Makes it simple. Do you notice that y stayed on the right side?
Yeah.
That is important. Y is not going to move around. Y lives on the right. Y is going to stay on the right. Okay? So now we need to do 72 minus 18. 2 minus 8? Can't do it. So I'm going to borrow from 7, make it 6. 2 becomes 12. 12 minus 8? 4. 6 minus 1? 5. So I get 54 equals y. Yes? Y is the y on that side? Because the y was on that side to start with. All right. So for number 2, I got my answer is 54. Raise your hand if you can tell me how am I going to set this up to check it. Let's see if we can get that in the correct order. Jonah.
You do 54 plus 18.
That is not what I'm looking for exactly. Ryan?
Never mind.
Brandon?
54 and add 18.
That's what Jonah said. Not what I'm looking for. Jacob?
72 minus 18.
Not what I'm looking for because we already worked that out. If I did it once, I'm just going to maybe make the same mistake. Dylan?
54 minus 18.
Not what I'm looking for. Evan? Why? Because I highlighted it. Guys, look at what's highlighted. My problem. Did it say y plus 18? No. If it said y plus 18, then I could do my 54 first and then plus 18 at the end. But look, this says 18 plus y is at the end. What is y? 54. So guys, you're literally just rewriting that problem but with the number plugged in. So we're going to do 18 plus 54. Okay, so 18 plus 54. What do I get when I work that out? 18 plus 54. Jay? 72. 8 plus 4 is 2. Carry the 1. 1, 1, and 5 is 7. Is that what I was looking for? Is that what was on the other side?
Yes.
Yeah. Check. We got it correct. Okay. Anderson?
Why can't it just be 54? 18
All right. It can't be. Shh.
Let's do the same answer.
But what did the problem say? Did the problem say y plus 18? No. So if I'm checking the problem, I have to do the math exactly like the problem, which says 18 plus the y, which is the 54. All right? And that works out. It works out either way because of addition. Anderson, are we always going to be adding? No. So let's make sure that we can put that in the right order for every problem, okay? All right. Number 3. What number needs to be, what am I doing on both sides? Just tell me real quick. What am I doing on both sides on number 3? Jay?
Subtracting by 1.5.
Subtracting 1.5 on both sides. All right? So 8 minus 5 is 3. Keep my decimal. Make sure you line them up. 9 minus 1 is 8. That line tells me that's where my equal sign goes. My 1.5s go away, leaving me with n. I should get 8.3 equals n. And guys, I do expect y'all to be able to do it at that speed by the end of tonight's homework. Not maybe at the beginning, but definitely by the end. Okay? All right, let's check it. All right, again, I'm going to highlight that problem. So hopefully we'll be able to check that in the correct order. How am I going to check this one? Kaya? 8.3 plus 1.5. Why did 8.3 come first this time? Because n came first. It said n, which is 8.3, plus 1.5. So let's add that. 3 plus 5 is 8. 8 plus 1 is 9. Is that what we expected? Yes. Okay. All of those problems up there, did you notice we were adding, right? And the opposite of that was to subtract. Now we're at subtraction. I'm still going to work these pretty much the same way. Draw my line. What operation is happening? Subtraction. So what are we going to do? We're going to add. We're going to do the opposite, which is to add. On number 4, raise your hand if you can tell me. What number am I adding to both sides? Joelle? 2. Because that's the one that's with my letter. All right, and why am I adding? Because that's the opposite. All right, so I want you to kind of look over at this board with me real quick. Y'all see where my minus 2 is? There's minus 2. Y'all see right here? There's my minus 2. I'm going to add 2. You ready? 1, 2. What did I end up at? 0. So if you're at minus 2 and you add 2, do y'all see on this number line how we ended up at 0? Can you see where I'm at, Cameron? Can you see that? Okay. All right. So, minus 2 and plus 2, that becomes 0. So that gives me just W. And what's 9 plus 2? 11. All right? So when they're opposites, guys, they're going to cancel out. A minus 2 and a plus 2, negative 2 is minus 2, they're the same thing. So minus 2, 1, 2, count over to the positive side, gives me 0. Okay? All right, Cameron? It's a minus 2. And a negative and a minus sign look the same because they are the same. For right now, guys, all you need to know is minus 2 and plus 2 are opposites, so they're going to cancel, giving me 0. So, for example, Cameron, for example, let's say, I'm trying to think of how I could word this. Okay, let's say, for example, you have, I want you to think about a bank account for a second, okay? Think about your bank account, okay? Let's say you have, your bank account right now says negative $2. It says negative $2. Do you have any money in your bank account? No, in fact, you owe the bank some money right now, okay? So your bank says negative $2, right? But then you go to the bank and you put $2 in your bank account. Is that going to say $2 are in your bank account? No, it's going to say there are 0. Because what the bank did was they took away, they did minus $2 because that's what you owe them. Well, then you gave them 2 plus 2, and now you're at 0. Does that make sense how we're getting the 0? Okay. All right. So, W equals 11. How am I going to check that? How am I going to check that? Someone who I haven't heard from. JC.
11 minus 2.
11 minus 2. Why did the 11 come first? Because the W came first, and then it said minus 2. Be careful, because when you're checking, you should always be doing what the problem said, not what you did to get your answer. So do you see how you're going to add on one, then you're going to subtract on the other? You're always doing opposites there, okay? What's 11 minus 2? 9. Because here's my hint, guys. You should never be checking by doing the same thing. You're just going to make the same mistake. Okay? All right. Number 5. What am I doing to both sides? Aaron.
Subtracting 17.
Ooh, adding 17, because that's the opposite of subtraction. So adding 17. All right, 4 plus 7? 11. Carry my 1. 1 plus 8 plus 1? 10 equals, what's going to happen to my minus 17 and plus 17? It's 0, so what's left over there? F. Okay, so there's my answer. 101 equals F. How am I going to check that? How am I going to check that? Jay. 101 minus 17. Exactly what the problem said. Perfect. All right, 7 minus 1. Can I do that? No. So what I'm going to do is I'm just going to borrow from 10 because I can't borrow from 0. So I'm going to borrow from 10, which makes it 9, and my 1 becomes 11. 11 minus 7. 11 minus 7 is 4. 9 minus 1. 8. Is that what I was expecting? Yes. So check. We got the right answer. All right. Number 6. We got to remember how fractions work, but we can do this. All right. What am I going to do to both sides? Both sides. What am I doing, Jacob?
You're gonna make them make the denominator even. So what
Not yet. What am I going to do to both sides to do my math? What am I doing? Okay. Adding 1/2. You got to add 1/2. Before I can worry about those denominators, Jacob, I got to know I'm adding, okay? All right, what's going to happen to my minus 1/2 and plus 1/2? Jacob?
it's gonna be
Yeah, those are going to become 0, so I just have x equals. All right, so now we can get into what you were talking about. All right, now it says 2/5 plus 1/2. Can I add those the way they are? No, that bottom number, the denominator, has to match. My denominator, bottom number. All right, what's a good bottom number for 2 and 5 to have in common? Hayden? 10. So I'm going to multiply 5 by 2. And if I do it to the bottom, to the top. So let's fix the first fraction. 2 times 2 is 4. 5 times 2 is 10. So my bottom number is 10, which is what we wanted. All right, let's change this bottom number. I need it to match 10, so I'm going to do 2 times 5, and if I do it to the bottom, do it to the top. So now I have 1 times 5, which is 5, and 2 times 5, which is 10. Now do those have the same bottom number? Yes? So when I add them, what do I get? 9/10, okay? So guys, real quick, I got x equals 9/10. Does 9/10 simplify? No. If it would simplify, do you need to? Yes. Guys, if the fractional simplify, you need to. I'm warning you right now on your homework, there's somewhere that'll simplify, okay? All right, guys, we got to check this. I know it's a fraction, but we're up for the challenge. All right, pay close attention. Please stop tapping our feet. Thank you. All right, so it says x. What's my x? 9/10 minus 1/2. All right, to subtract those, I need the bottom to match, so I'm going to multiply 2 times 5, and the top times 5. So now I have 9/10 minus 5/10. Wait, we got to go the right way. 9/10 minus 5/10 is 4/10. But will 4/10 simplify? Yes, we can divide those both by 2. All right, 4 divided by 2. 10 divided by 2. 5. Is that what we had originally? Yes, so we got the right answer. All right, you guys, I know checking on the fractions a little bit longer, but it's some good practice with our fraction work, okay? Did I slide that over for you? Good. All right. We got 2 more to look at. 2 more to look at. I'm going to try to make these as painless as possible. Jeff is 48 years old. This, the 48 years, is 25 years older than Seth. That should be than, not that. Write and solve an addition equation to find out Seth's age. What am I looking for? Seth's age. So what is my variable? Seth's age. And I'm going to use A because y'all said sometimes my S's look like 5s. So I'm going to say A is Seth's age. If you want to use S, that's absolutely fine. So A is Seth's age. Guys, it says write an addition equation. So guys, that means I'm going to have A plus something. I just got to decide. Okay, I got 25 and 48. Which number is it that I'm actually adding to Seth? 25. Thank you, Jay. Next time, wait for me to call on you, okay? Thank you. All right, so we're going to add 25. And when I add 25 to Seth's age, what should I end up with? 48. I should end up with how old Jeff is. All right, so I get, there's my equation. A plus 25 equals 48. Do y'all see how I was able to work that out? It told me addition equation, so I just had to decide, okay, what number am I adding? All right. Now we've got to solve it. So I'm going to do minus 25. Minus 25. Look, I'm doing it without the line. If you want the line, you can always draw it in, okay? So that gives me A equals, please stop, gentlemen. 8 minus 5 is 3. 4 minus 2 is 2. So I get 23. Remember, you should be writing this down, please, Aaron. All right, Seth is 23 years old. Okay. So I have my equation and I solved it. Yes? It's 5 letters. Just write it. Okay, it's 5 letters. Don't get shorthand with me. All right, yes, Jay. I'm not going to check this one now. I'm only really focused on checking those top ones. Sorry. Let's get this last one done real quick so y'all can have some homework time. All right.
Should we check?
Brownies. You can check it. Always check
Are
it.
we expected to check?
That's up to you. I'll leave that one up to you on the work problems. Okay. All right. Brownies have to cook 28 minutes longer than sugar cookies. A batch of cookies takes 7 minutes to bake. Write and solve a subtraction equation to find out how long the brownies have to cook. So what is my variable going to be here? What am I looking for? Evan. All right, but I need more than just brownies because what is about the brownies? How much sugar I need, how much batter there is, how many brownies it's going to make. What are we talking about with the brownies? I need more information. Lexi? It's that whole thing, how long the brownies have to cook. So guys, I am going to shorten it. I'm going to use M, or we can use B. All right, for brownies. But I'm going to say minutes, because that's how we're measuring it, isn't it? Minutes, brownies, cook. Does that tell me that it's how long the brownies have to cook? Minutes, brownies, cook. It's just a little bit shorter than having to write out how long the brownies have to cook. But you got to give me how long they have to cook, okay? Either you're writing this whole thing out or you're writing that.
All
right.
Brownies have to cook.
Yeah. No. All right, so right here, we're doing a subtraction equation, right? So I'm going to have B, and I got to take something away. What am I taking away? The 28 minutes to give me 7 minutes for the cookies? Or am I taking 7 minutes to give me 28 minutes longer than the cookies? All right, let's think about that. What am I taking away here, Drew?
28 minutes because you can't minus 7 to get 28. Unless it's...
Technically you could because it's going to be bigger. Yeah, technically we could do the minus 7 to get 28. But guys, what makes sense to me when I read this, if the brownies have to cook 28 minutes longer, if I take that time away from the brownies, that's going to leave me with the time for the cookies, which is what we have here. So there's my equation. All right, and now we're going to solve it. So if you want to draw that line again, draw lines. What am I doing to both sides?
Adding 28.
Adding 28. So I get B equals
35.
35. Thank you. So now my sentence, I'm going to say brownies cook for 35 minutes. Alright guys, and you actually don't even have any work homes on tonight's homework. Alright, we will see them later this week, alright? Homework's on the back, solve and check.
What about a homework test?
Homework's on the back, solve and check. It's our first time doing equations, we have to complete it. No.
What about homework tests
Homework.
tomorrow?
We're never allowed to do homework after this class.
No, because it's math.